So, dear friends, good evening. Welcome to Wings of Hero. I hope all of you joined. We will continue our session. It's already time up. So, we have done with our two major components, right? One is our fuselage, and other one is our main wing. Okay, and also we have used aerofoil Boeing 737 ABC aerofoils at root side, kink side, and tip side. Okay, just you have to go to downloads, you have to go to open VSP folder, and you have to use first option, aerofoil option. As soon as you click on that first option, aerofoil option, then you can able to find set of aerofoils. Okay, here Boeing B737, and this is Boeing 737 A, B, C, D. You can choose any one of this and you can add. Okay, that is what we have done. And today, sorry, okay. So today we will go with the horizontal stabilizer and vertical stabilizer. After that, engine component. If time permits, then we'll go for assembly also. Okay, yes. So quickly we'll complete this all three sections. So here we have horizontal stabilizer. Also we have the given data. Overall span 23.77302 feet. Chord 9 feet. Area. So no need to split this section. Only we have to use only one section. Root chord 13.5 feet. Tip chord 4.5 feet. Just 2 minutes. Okay, sweep angle 35 degree, diagonal 8 degree. Aerofoil, you can choose that Boeing ABC, any one of that, or else you can go with NACA 4 series aerofoils. Okay, yeah. So we'll use all these parameters and we'll complete our horizontal stabilizer. All of please note down these values. So we will come to our open VSP software. Run. Here we have our side view, front view, and top view. So we are dealing with this component, horizontal stabilizer, this one. Okay. So we have to come to open VSP, go to geometrical browser, select wing and add. So here we have our default wing. Now to this default wing, we have to give our parameters. Okay. Here to here, overall span 23.77305 feet. Okay, come to platform. So here we have to give overall span for this horizontal stabilizer. So let me check that. Okay, wait, sorry. It's b by 2. Okay, it's b by 2. B by 2 in the sense this one, from here to here, because we know overall span is b. So b by 2 in the sense this, from root chord to tip chord, span b by 2, 23.77302 feet. Okay, so 23.77, you can calculate that into 2, so you'll get 47.54. Okay, I just want to keep the symmetry. Okay, so that's why we have to use overall span from this end to this end. Okay, from this tip chord to this tip chord, overall span is 47.54 feet. Enter. Because we know span length 23.77 into 2. So 47 we have. Okay, you can round off to 47 like this, since it's calculated value. Okay, 47 feet 1 inch. So we'll just round off to 47.5. Okay, that is our overall span. And chord length, this one, 9 feet. Seven, 8, 9. Okay, so I'll just type 9, enter. Done. So after this, okay, so whatever will get the area automatically, let it be, no need to do any disturbance. Okay, so currently we have only one wing section. No need to split this wing, because here we can observe just wait, let me fix this properly. Okay, the wing is like this, no? So of course, easily we can use our complete wing section without splitting. Okay, we can achieve this kind of shape. Okay, so which means only one wing section is enough, no need to split. So that's why in open VSP, in the section, I'll be keeping same as it is, only wing section. Okay, I'll be not going to split the wing. Only one wing section we have. Okay, see now in this one wing section, we have to check our values, whether we have given right values or not. So overall span you have mentioned here, so automatically it will show here. I mean, like, it will implement here. Okay, now the only thing what we have to do, we have to give root chord and tip chord. Root chord 13.5 feet and tip chord 4.5 feet. Root chord 13.5, enter, and tip chord 4.5. Okay, yes, done. Now after that we have to give sweep angle 35 degree. Okay, sweep angle, this angle 35 degree, and that is what mentioned here. Okay, so sweep angle default we have 30 degrees, we have to change this to 35, enter. So after this, dihedral angle. Why we have to maintain dihedral angle 8 degree? Because you can observe, okay, the wing, okay, here this one, it's not completely horizontal to the ground level. Okay, so this wing little bit tilted towards upside, that is called as the dihedral angle. Okay, this one, this angle is 8 degree, so that is our dihedral angle. Okay, so here we have to come to dihedral, and see, it will change now. I will use front view. Okay, I will just change this angle 0 to 8 degree. See, okay, yes, so we have done with all the parameters. The only thing is that we have to come to the aerofoil, and if you want to maintain the same default aerofoil, let it be. If you want to read your file, you can go to aerofoil type. I mean, like, you can choose the type of aerofoil. So let's go with AF file, read the file. Okay, so here we'll copy this one and we'll paste here, Control V, enter. Okay, so you can choose any one of this. B, Boeing 737 A, B, C, D, you can choose any one of this. I will just choose A. Okay, accept. So automatically name of the aerofoil it will implement here. The name is Boeing 737 A. Okay, which is having a thickness to chord ratio 0.1537. Okay, 15.37. Okay, percentage thickness to chord ratio. Or else you can choose the series aerofoil, NACA series, 4 series, or 5 series, or 16 series, like that. Now let it be. After that, what you have to do, just you have to shade, and you have to check your views. This is your left ISO view, and here you have all the views. ISO view, top view, side view, and front view. Okay, so you have to save this one. I will just come to the folder. Okay, I will save here, because yesterday we have done with these two parts, and third part I will just save here itself. I'm like in this directory. Copy, go to file, use save as option, and paste your directory and give your file name. Part 3 horizontal stabilizer. Accept. Okay, so we have done with our horizontal stabilizer. You can ensure your file. Okay, horizontal stabilizer, it's already saved. Now again go to file, go to new, because now we'll be dealing with next geometry, that is our vertical stabilizer. This one. Okay, this one. Yeah, so okay, here we have vertical stabilizer parameters. Yes, don't wait for geometry. Of course, you know how to use all these parameters. Just continue. Already have shared all the data, right? Okay. So here we have our views with parameters. I mean like dimensions. This is our vertical stabilizer. Of course, we have to split our wing into two sections. From here to here, first wing section, and from here to here, second wing section. Okay, so first one and second one. Overall span, it's a symmetry wing. We have only half portion, so that's why b by 2, it's 27 feet. Okay, so which means root chord to tip chord, overall b by 2, it is 27 feet. Okay, we have to split our complete wing into two sections, 1 2. That is what we have to do in our open VSP. Section 1 parameters, it is mentioned here, and section 2 parameters, it is mentioned here. Okay, just proceed. This is for this section, and this one is for this section. Okay, at the end you can choose any type of aerofoil. So we will go to OpenVSP software, go to geometrical browser, select wing and add. Okay, so we are dealing with the vertical stabilizer. Okay, so no need to keep the symmetry of our model along XZ plane. Okay, so that's why we have to off this checkbox. Okay, yes. Overall span, okay, that is b by 2, 27 feet. Come to OpenVSP, come to platform, give overall span, that is b by 2, 27, enter. Okay, Now after this, chord length, it's 16.22, sorry, 16.20223 feet. Chord length 16.20. We'll just round up to 16.20. Okay, enter. Okay, so whatever will get the area in open VSP, let it be. No need to do any changes. Now directly we'll come to section. Yeah, so here we have to split our complete wing section into two form like this. First one and second one. First wing section and second wing section. Complete wing section has to be splitted now. So we have to split. So complete wing has been splitted in two form, first wing section and second wing section. So we'll come to first wing section and we will use first wing section parameters what we have here. Okay, this one. This is for this wing section. Okay, yes, go ahead. So span, which means this one, 6.5 feet. Six point five, enter. Root chord, this one. For first section, this one will be root chord and this one will be tip chord. So root chord of this first wing section, it is 30.5 feet and tip chord 14.9 feet. Root chord 30.5, enter, and tip chord 14.9. Okay, enter. So we have done with this. Next, sweep angle 69 degree. Okay, this sweep angle 69 degree. Okay, diagonal angle, no need to do any changes, let it be 0 itself. See what will happen if I disturb to the twist. Okay, I mean like sorry, not to twist, sorry, to this diagonal. So it will just get tilt. right side and left side. So we don't want such shapes, right? We want to maintain our vertical stabilizer perpendicular to the horizontal stabilizer. So that's why this angle should be 0. Okay, yes. So first wing section is done. Now we will jump to second wing section. Okay, just jump to second wing section. So this green box indicates you are in that section. Which section? Second wing section. So we have our parameters. Span of second wing section 20.5 feet. From here to here, the length is 20.5 feet. This is our span of second wing section. .75. Enter. Okay. Sorry, 20.5. 20.5. Sorry. Okay, yeah. And after that, root chord 14.9. Of course, for second section, root chord is 14.9 itself. Okay. First section tip chord will become second section root chord, and the tip chord of this second section, it is 4.411 feet. So just we have to type 4.411, enter. Okay, done. 4.411. Hit enter. Okay, done. So after that we have sweep angle 36 degree. Sweep angle, it's 30 degree. We have to change this to 36. Enter. Done. And after this, of course, diagonal angle, it should be 0 itself. Okay, we have done with our vertical stabilizer. Okay, yes, you can share this one and save. Go to file, use save as option, and call this one as part 4. This is our vertical stabilizer. Accept. Okay, yeah. Now we have to go to file and new. Why new? Because now we have to deal with the engine component. Okay. Yes. So in our open VSP, we can achieve this kind of components. Okay, engine type of components by using geometrical browser, because in the geometrical browser we have the option, inbuilt option or inbuilt geometry called as duct. You have to select that and you have to add. Okay, Go to view, fit on screen. Okay, this duct is like a engine itself. Okay, so you can use this default engine, because here uh, let me come to the views. Okay, here we don't know our engine length and all. Okay, overall length and dia and all. So what I'll do, I'll just give all these parameters to you. Use these parameters. Okay, width, height, and shape, chord, thickness to chord. Okay, so by using all these parameters, we'll complete our engine components. What I have done, we have chosen the deck component and we have added. As soon as we add, we can able to see in this open VSP, the deck has been added up. Okay, so with respect to this duct, we'll get the parameters. Okay, we have to go to this design tab where we can change the width, height, and shape, chord, thickness to chord, camber, and camber location. You can observe here we have aerofoil shape of geometry. Okay, you can use none option. Okay, see here. So the profile of our engine is like this. It's a default profile, so we have to change this default profile and we have to use all these values. Okay, so go to design and give this value width 5.501 feet, width 5.501, enter. See, suddenly width got changed. Next, height 5.042 feet, or else you can round up to 5 feet, no worry with that. Okay, so just go with this height 5.042 feet, 5.042 feet, enter. Okay, so width is done, height is done. Next, shape. See what will happen if I increase. You can observe here the engine shape or the engine component. It's not like a circular type, right? It's not completely circular. So that's why what we have to do, we have to change its shape. Okay, let it be. Okay, so we'll round off to minus 0.2 or 25. Okay, now just what we have to do, we have to increase the chord length. Chord length in the sense engine length. Okay, now see here we have top view. Engine length is very small. Okay, here we have seen the profile of this engine. It's aerofoil shape. So of course, here we have leading edge, trailing edge. From leading edge to trailing edge, the straight line, that is our chord line. So just we have to increase the chord line. That's it. By increasing the chord line, we can increase the engine length. Okay, you can shade like this, you can observe. Okay, so here I have mentioned how much chord length you have to maintain, that is 10.5 feet. So we'll go with 10.5, enter. Okay, and thickness to chord ratio, go with 12%, 0.12, enter. Camber location, we'll go with 0.3. Okay, sorry, wait, 0.3. Okay, now once again we'll shade this one. Yes, so just come to general. Okay, you can smooth this geometry by using these tessellations. I mean, like, you can increase number of tessellations. See, because the geometry is not smooth, here you can observe there's a gap here. Okay, which means geometry is not smooth. To smooth this geometry, we can increase the number of wireframes or tessellations like this. So now there is no gap. Okay, yeah, yes, it's done. So just go to file and save. This is our part 5. Engine component or duct, except. Okay, so we have done with all the 5 parts. Let me check part 1, part 2, part 3, part 4, part 5. Okay, let me call each and every part. I'll just go to file, open. This is our part 1, fuselage. Okay, part 2, main wing. Okay, part 3, horizontal stabilizer. You can change the wireframe color like this, no problem. Okay, part 4, vertical stabilizer. And part 5. Wait, let me fit this on screen. Now we'll do assembly. Okay, see, I have increased number of tessellations, so that's why the geometry is very smooth. I'll just decrease the number of tessellations. It's 89, too much. Okay, okay, let it be. Okay, so once again we'll save this one. Okay, yes, so now we have to go to file, go to new. Okay, now we have to call all these parts, part 1, part 2, part 3, part 4, part 5, and we have to complete our assembly. So what we have to do, we have to call all those 5 parts. After calling, we have to assemble, and at the end your model will look like this. This is our top view. front view and left side view. Okay, so we'll complete that one also. Still we have time. Okay, we'll do that. So go to file, go to insert, call each and every part, select first part and accept. Next, again go to file, insert, select second part and accept. Same, select third part, accept. So here we have third part. I will just use this X location, X form tab. Okay, and oh, sorry. Okay, okay, okay. So we have called three part: fuselage, main wing, and this is our horizontal stabilizer. So we will just come to general. Okay, I mean all of you come to general and change this name. So default we have wing geometry, that is our name. So we have to change this to horizontal stabilizer. We have to give our name. Just to avoid the confusion, that's it. Enter. Okay, and this is our fuselage. Okay, main wing. Okay, horizontal stabilizer. Okay, yes. Again we have to go to file, use insert option, click on insert and call fourth part vertical stabilizer. Accept. So this is our vertical stabilizer. Just we have to change the name. Vertical stabilizer. Enter. Again go to file, insert, select fifth part and accept. Okay, so this is our duct. You can call this one as duct or engine component. Enter. Okay, so what we have done, we have called all the parts which we have designed. Okay, by using our open VSP software. So we have to assemble all these parts. At the end your model should look like this. Okay, so what we have to do to assemble, we have to fix any one component. Okay, so I will select fuselage, that is our main component. I'm like major component among all the component. So we will fix this component, fuselage component or fuselage geometry. With respect to this fuselage, we'll assemble all other components. Okay, so I'll select main wing, use for tab. Okay, so translate this wing. All the components, they are settled at one place, so let me separate all this component. So I'll just type 20. Okay, and I'll choose the horizontal stabilizer. I'll move this one. I will take this to backside. I'm like along x, positive x, 50 feet away. Okay, okay, I'll just keep here, let it be. Now I'll select vertical stabilizer. This one also we have to displace from here to here. Just 2 minutes. Sorry guys, we'll continue. Okay, so here we have vertical stabilizer. This one also I'll just translate along x. Just type 100. Okay, let it be here itself. And here we have our duct component or engine component. I'll translate this along z. Okay, let it be here. Okay, so we have our main fuselage, main wing, horizontal stabilizer, vertical stabilizer, and engine component. Okay, so we have fixed our fuselage here itself. Now we will select the main wing and we'll fix this wing. Okay, I will use two window. Okay, okay, so we have to fix in this manner. We have to translate our wing. Along x 45 feet away. Okay, from here to here, x location it is 45 feet. Just type 45, enter. Okay, now, oh yes, let me check the front view. Okay, yeah, okay, we'll round up to minus okay, minus 2 or minus 2.5 feet. Okay, yes, so we have fixed our wing. Next we have to select horizontal stabilizer. Okay, we have to fix this one also. Okay, still we have to take back side. I mean, like, still we have to move this horizontal stabilizer back side, rear side, this side. We have to fix this side. Okay, so just type 100 feet. So from here to here, where that horizontal stabilizer is located, the distance is 108 feet away. Okay, so that's why along x we have to locate our horizontal stabilizer in such a manner that the length along x should be 108 feet away from this point. Okay, just type 108 feet, enter. Okay, done. Okay, and it is somewhere here, which means what we have to do, we have to use our z location. Okay, and we have to fix at a distance of 5.5 feet. from ground level. Okay, this one. From here to here, the distance is 5.5 feet. From here to here, sorry, let me write clearly. 5.5 feet. Enter. Little bit down. Okay, so we'll round up to 5.5. Just let it be. Okay, so we have fixed our horizontal stabilizer. Next, what we have to do, we have to select vertical stabilizer. Let's select only one window. Okay, so it is completely parallel to the plane. So we have, it's completely parallel to the horizontal stabilizer. Okay, so we have to place our vertical stabilizer perpendicular to the horizontal stabilizer. So which means we have to rotate this vertical stabilizer along Z rotation. Okay, sorry, along yeah, here we have x-axis. So vertical stabilizer we have to rotate along x rotation. Okay, like this, which means 90 degree perpendicular. Yes. Okay, yeah, so we will use two vertical window so that it will be clear to fix. Yes. Okay, so after this, what we have to do, we have to locate this one here, that is at a distance of 93 feet, 93.58 feet. Okay, and along Z, okay, 6.5 feet. Enter. Okay, done. So we have fixed our vertical stabilizer. Okay, yes, so now what we have to do, we have to select the engine component and we have to use front view. Okay, just we have to place here. Minus okay, so along Y we have to displace this engine component 25 feet. Okay, 25.8 feet. Sorry, it's 20. Wait, we'll use four window option. Okay, now it will be easy to fix. Yeah. Okay, it is here. So we have to move this one and we have to fix below the wing. Okay, now currently it is here. So we'll just translate this along x. So along x it is 60.478, and along y, okay, it's 25.8. 3 enter, and along z, okay, let it be, okay, it is just below the wing, so we'll round off to minus 3 point or minus 3. Okay, so it's fixed. Now no need to do one more wing, just you have to copy and paste, that's it. Okay, you have to copy this component and you have to paste. Okay, so as soon as you paste, you'll get one more component. So just you have to translate this component. Okay, so you have to translate this component along x, y, and z, and you have to fix here just opposite to this. Okay, so we'll use for window option. Okay, yeah. So we'll go with minus. Okay. Wait, x location. We'll go with 0. And along y, okay, opposite. This one, how much we have? This wing. Okay. Just 2 minutes. It got hang. Oh shit. Sorry. Actually, it got hang. It will take time. Just 2 minutes. So we have done. Okay, we have done. If I close, automatically everything will close. What you have to do? Just you have to copy and paste. That's it. Okay. We'll stop here. Tomorrow we'll do assembly. Okay. Once again, I will show roughly. I think it's already time up now. Okay. So what you have to do? Just you have to copy your engine component. That's it. If you have any questions, you can unmute. So it's not working. Okay, I will just check with the software. I have to update. That's it. I will do that. Okay. Yeah. So I'll go to question and answer session. Yes. There is one question from okay, Dikshita. Sir, how to fix component? Your components are ready, right? All the 5 components. Okay, call each and every component and fix. That's it. So don't worry. Tomorrow once again I will show how to assemble. Okay. I hope all of you have all the 5 components. Okay. So just go to file. There is some problem. We'll stop. We'll stop. Okay. We'll continue tomorrow. By the way, we have saved all the files. Yeah. Questions. We'll just go to question and answer session. So Dikshita, no need to worry. Okay. Tomorrow we'll do the assembly part. Yes. You Ashri. We can. Just you have to use symmetry. That's it. Okay. Yeah, that's right. Yes. That is what I told you. Can do the symmetry. You can use symmetry option. Any other queries? Any other question? So all of you, please call your all the parts. Go to file. Use insert option. Okay, and complete the assembly. What I have shown. Okay, use same method. Translate your each and every component and fix accordingly. Okay. So shall we stop the session? I don't think so. Any questions from your side? If you have any such questions, just unmute, use mic or use chat window. No, okay. So Bhuneshwar sir, okay, we'll stop the session. We will continue tomorrow. Okay, thank you students. Okay, thank you to all of you. We will continue tomorrow.